Happy New Year, everyone. I'm Alex, and this is my project, Project Enoch, a retro-styled sci-fi shooter. So, a lot has happened since my last video. I switched to a new engine from a fork of a engine called Iron Whale to a more flexible Quake World-based engine called FTE-QW. Made by the FTE team, which led to me discovering a whole new side of the Quake C programming language. Back in August, I set out to rewrite my whole game from scratch, and designing a new enemy spawning system for my game. I took advantage of features like class inheritance and custom types. So here's an outline of this new system. At the heart of this new system are these wave class entities. These entities control what spawns in a play space and what non-player characters do when they're in that space. So you have your play space. Those wave entities will be in the space controlling everything in the space. Some number of these wave class entities trigger one another in a sequence, and starting with an initial wave, so this one, and ending with a final wave. And that controls the perpetual behavior in that space. These waves send predetermined instructions to the subsystem to spawn enemies called the spawn controllers. And it receives instructions from another subsystem to provide enemies in the play space with context for navigation and combat called the objectives. So that might look like this. We have our objective entity and I have an objective area and some points of interest associated with that objective. And the objective will be associated with that initial wave. All right. So how is this set up in TrenchBroom? So here's how the system looks in the editor. These green cubes are the wave class entities. The target and target name fields are used to link each wave entity for this play space in a chain. You can see the red arrow pointing from one wave entity to the next. The information in the fields frags, health, style, runtime min, and runtime max are sent to the spawn controller indicated in the noise field. The wave's health is the total number of enemies that can be spawned in this wave. Frags indicates the number of those enemies that the player has to kill before the next wave can start. Style is used to set the kinds of enemies that will be spawned during this wave. It is a bit flag field with bit flags representing different enemy classes which can spawn. The runtime fields contain the number of enemies that can be spawned by this wave entity at a single time. If there are too many enemies, the wave will wait for the runtime value to drop below the maximum threshold before spawning more. If there are too few enemies, the wave will spawn more enemies early without waiting for the full respawn time. The respawn time field determines how frequently the spawn controller should be used. The spawn controller is a simple entity with a target and a target name. Its target name matches the noise field of the wave entities that use it, and its target field points to each spawn point where respawning enemies can be spawned. Each time the spawn controller is used, it tries to spawn as many enemies at a time as it points to spawn points. Enemies which spawn together are grouped into an invisible squad class, which helps these enemies work together as a team, following the same behavior patterns and distributing Positions of interest on the battlefield. The waves of enemies are kicked off by an entity called the objective class, which targets the first wave in a chain. And the noise field of the objective entity points to a group of entities used for NPC navigation. This string is passed from the objective entity to the active wave, to the spawner controller, to the squads of enemies, which use this string to assign points of interest for each member of the squad to travel to. All the squads of enemies assigned to an objective belong to an invisible class called a platoon, which is used to send messages from the objective to the squads. For the objective class, frags represents the minimum number of enemies that must be assigned to this objective before it becomes activated. The objective continually looks for new enemies which do not belong to a platoon to assign to itself. Squads of these enemies are found in the unassigned list. Until the objective is activated, it won't call any of the assigned squads of enemies to navigate to the points in its group. Once the objective is activated, it calls the assigned squads to these points for the first time, and also assigns behaviors using the armor type control and style fields. The armor type flag explains to the squad what kind of objective this is. The default value of 2 identifies this objective as an area to guard. The control bit flag blocks certain action states in the enemy behavior tree from being used by enemies assigned to this objective. The style bit flag is used as the opposite of the control bit flag, so enemies assigned to this objective have to choose one of the action states forced by this flag. The team flag indicates what the team the enemies will belong to when they spawn. And this system is more or less exactly what I had set out to implement last December in 2024, but I feel like now I have a much stronger understanding of object-oriented programming using C-like structures. So this character that I've been using to demonstrate the spawning system is a prototype model of a sci-fi police officer. So in the world building of Project Enoch, we have the military taking sort of a backseat role to organizations like city police forces, peacekeeping forces, and reserve forces, things like private military contractors, military police. So it would be fitting to have some heavily militarized police uniforms in this game. So this is my rendition of a heavily militarized police. It takes some inspiration from American police as well as international police, and you can probably see the inspiration from something like Halo's ODSTs or some Helldivers from Helldivers even a little bit. Just comparing some images here. We got the classic black and white color scheme. Eventually, I want to have some clearer markings that this is a police officer, but right now it mostly comes down to the marking or to the color scheme. We got sort of a slightly reminiscent helmet shape with a round helmet, and we got some shoulder pads and a bit of a tactical vest going on. But far more obviously, I'm taking inspiration from the ODSTs from Halo 3, and I really like this Helldivers rendition with the cape. And so I think what I want to do is add a cape to this guy. Another significant influence is European or specifically the London police, how they're always seen in these high-vis jackets. Not always, but very often seen in these high-vis jackets. In this case, I went with a more conservative-looking black and white high-vis jackets. Sort of look is what I was going for with the highlights here. And then I do think the cape would be fitting for a police officer. I mean, the Italian carabiners are pretty cool looking, so that's my excuse for putting a Helldiver style cape on this guy if I get around to it. So I chose this guy as a placeholder enemy for this prototype as sort of a basic example of a biped character. I think this design would be pretty easy to colorize, and that could help me prototype more complicated scenarios where it'd be nice to have different teams or different squads colorized. So that was part of my reasoning for choosing him for this prototype. When he appears in actual single-player levels, he will most likely be an ally and not someone you have to fight. I want players to say, hey, this guy is cool. Like when you fight alongside the ODSTs in the beginning of the campaign mission, the Ark in Halo 3. In terms of just talking about this model real quick, the model has a lot of room for improvement. This was the last model I designed before I realized I could rip individual faces along their normals to help me bake simplified meshes without having to fully enclose the higher level detail version of the model. Trying to fully enclose the detailed models was causing me to make my characters unnecessarily chunky, and also limited the number of fully modeled accessories that I could bake into my game models, because each detail forced me to either grow the mesh or add a simplified extrusion. The consequences of manually ripping each face along the normal are twofold. Now I have to maintain two versions of each low poly model in addition to the detailed models, and every time I modify the UV map of my game model, I have to duplicate that modified model and rip the normals all over again to not intersect the detailed mesh. I have not discovered a simple way to link upstream changes to the ripped model yet. The second consequence is that when I bake the textures for these models, I get little seams between each face, and this isn't a big deal, but it's one more thing I have to be aware of. I also need to change the orientation of the hands on all of my bipeds. I've been designing all of my models in an A pose with their palms down, but in most animation frames, my models need to have their palms forwards, like when they're walking or holding a weapon. I can always rotate the wrists throughout the entire animation, but low poly models deform in a somewhat unnatural ways, and it'd be better to design the arms at the rotations they will actually be seen in. This is an eMachines eMonster 600. You can see it proudly proclaims to be never obsolete and the world's best gaming machine. It's got a 600 megahertz Intel Pentium 3 CPU and an NVIDIA Riva TNT 2 graphics card, 64 megabytes of RAM. It was part of eMachine's Never Obsolete program, where they would replace parts of your computer after 2 years if you were enrolled in the eMachine's network and shipped to your computer in the original packaging and paid a $99 upgrade fee in addition to paying for shipping both ways. The program came bundled with their dial-up internet service for $19.95 a month, and it seemed to have been stopped being advertised on their new PCs around the time that the first computers would have actually started to qualify for this program. Naturally, this device can only connect to a phone line unless you use USB to Ethernet. And it has this mysterious gaming port. in the front. So this eMonster 600 is not a genuine example of a 20th century computer, since multiple components show manufacturing dates in early 2000. However, this is its predecessor, the eMonster 500A, which definitely was manufactured in 1999. You can see the difference in the specs on the front. Now we can actually boot this thing. Yeah, it's totally fucked, but this is Windows 98 with all the eMachines bloatware that it would have came with in 1999 or 2000. Normally you would have a neat little taskbar down here that would show period correct advertisements for our enjoyment. I should have a photo of that. But the reason I went and bought these computers isn't just because I hate myself. It's because I thought if I'm going to develop a retro game, I should be targeting real vintage hardware. And so, well, the actual release version of Project Enoch won't be able to run on this computer. It doesn't look like anything's going to be able to run on this computer. But I want to develop my game with the intention in mind that I could eventually port my game to this system in the future. To me, these specs look to be right in the sweet spot. This is pretty top of the line for the end of the 20th century, which makes it perfect for a heavier Quake mod, but not quite the minimum specs to play something like Halo. And I'm yet to actually test any video games on this computer, mostly because I don't like how the GPU has no heat sinks on it at all, and the PCB is slightly brown on the reverse side. The GPU also has solder pads for the addition of a fan, which I am considering using if I get this up and running again. And yeah, that took almost an hour.